So what we're gonna do, I'm gonna steal their diagram as well. So in this next question, they have given us coordinates of a triangle. And the question is to show that the mid-segment joining the midpoints of PQ and PR is parallel to QR and half of its length. All right, that is quite the description. So we need to show that the mid-segment of PQ, so somewhere here, if we join this to the mid-segment of PR here, so that's the mid-segment of PQ, this is the mid-segment of PR. If we join this line, it should be parallel to this line and half of its length. So that is what we have to prove, right? How do we do this? So we'll first find the distance between the midpoints, and then we'll find the distance between QR, and we'll show that it's the same distance, or it's half the distance. So step one, let's find the midpoint between PQ, this line. What's the midpoint on the x values?
It's 0.
So for PQ, it'll be -2 plus 1 over 2, right? It won't be 0. It'll be what? -1 over 2. And this is 5 over 2. It's like 0.5, 2.5.
Mhm.
Or sorry, negative 0.5, 2.5. Similarly, we're going to do the same thing for PR. So it'll be -2 plus 4 over 2 and 2 plus -1 over 2. So this will give us 1 and 1 over 2. So those are the midpoints. How do we find the distance between 2 points? You're going to use the distance formula, which says this: the distance between any 2 points. You can always sketch it out and do a Pythagoras theorem. Like what you're supposed to do here is you do this, do a squared plus b squared, that will give you c squared. The formula approach says this: the distance is going to be x2 minus x1 squared plus y2 minus y1 squared, like that. So here, it doesn't really matter which one you take as x2, y2. I'm going to say this is x2, y2, this is x1, y1, and we're just going to plug it into this formula here. So this becomes 1.5 squared plus 0.5 minus 2 is 2 squared. And you just plug this in. So it's 4 plus 1.5 squared, the square root of that. So I get 2.5 units. So that's the length of this line that joins the two midpoints. How do we find the slope between these two lines? Or sorry, these 2 points? We're given this point and this point. The goal is to find the slope. Well, what's the rise? From 2.5 to 0.5, right?
Mhm.
What's the rise from 2.5 to 0.5? 2. What's the run from negative 0.5 to 1? It's 1.5. From 0.5 to 1, it's 1.5 units away. And this is going to be negative. So 2 divided by 1.5 negative, the slope is negative 4/3. So that's for the midpoint. We know that is 2.5 units in length. And we know the slope is negative 4/3. Now we're going to do the same thing for QR. What's the slope of QR? You're comparing this point with this point. What's the rise?
It's 4,
It's 4. What's the run?
3,
3. Is it positive or negative?
negative.
Negative. So notice the slope of QR and this mid-segment, the slopes are the same. If slopes are the same, but y-intercepts are different, then it is going to be parallel. So those two lines are parallel. And to show that it's twice as long as this mid segment, what we can do is we can find the distance between Q and R. And if we half it, we should get 2.5. So we're expecting to get a distance of 5. For this one, we can just use the triangle. Look at this. Since we already have the slope. The rise is 4 units, the run is 3 units. What's going to be the hypotenuse? What's going to be the distance between Q and R? You have a triangle with side lengths 4 and 3.
It's going to be 5.
It's going to be 5. So now we have proved everything, right? Because 5 is twice as 2.5, 2 times as big. That was the distance between the line segments. And we also proved that it's parallel because parallel lines have the same slopes, but different y-intercept. Cool?
Mm-hmm.
This one looks to be a little bit tricky. It says, show that the points AB lie on a circle with the equation of that. All right. If this is the equation of the circle, what is the radius? Remember how to find the radius if you're given an equation? It's going to be in the form of x squared plus y squared equals r squared. So if r squared is 125, what is r? R squared is 125. That means r will be the square root of 125, right?
Mm-hmm.
Like 11 point something. So we're given this point. That's our point A 10, 5. And B 2, 11, negative 11. So down here. So those are our points. What are we trying to prove? We're trying to prove that the perpendicular bisector of chord AB. So these two lines, they connect. This makes a chord within the circle. And we know the circle has 11.1. So 2, 4, 6, 8, 10, 11. So the circle would probably go somewhere like this. It looks something like this. So if it's a chord, chord is a line on a circle that connects 2 points.
Mm-hmm.
So we have this point here, 10, 5, that connects with this point down here. The question's asking us, all right, we're going to do this one by one. It says, show that the perpendicular bisector of chord AB. Do you remember what the perpendicular bisector is?
It's a line through the middle of that one, and it's 90 degrees.
Right, so it's going to be a line that's going to pass through the middle of this chord at 90 degrees. So step one, let's find the middle of that chord. What's the midpoint between A and B? You're given both points here. So between 10 and 2, what's in the middle between 10 and 2?
6.
What about negative 11 and 5? Just add them, divide by 2. That's all you have to do. So that's the midpoint. Right, we know the midpoint. It's 6 and negative 3. Right here is the midpoint. How do we use this to find the perpendicular bisector? Remember, the perpendicular bisector is going to connect with this point at 90 degrees. So what you do is you find the other slope and you flip it.
Mm-hmm.
So let's first find the slope of A and B. And again, you know how to do this. The rise is 16 units. The run is 8 units and it's positive, so the slope of AB is 2. What's going to be the slope of the other line that's perpendicular to this?
Negative 1/2.
Right, so it's going to be negative 1/2. So our equation for that line, wherever it is going to be negative 1/2x, y equals mx plus b. And we can only plug one point in here as x and y to find b. What's the point that we can plug in? Only one of them will
6,
work.
-3.
Yes. So 6 is equals to negative 1/2. Negative 3 is equals to negative 1/2 times 6 plus b. B is negative 3 plus b. So what is b equals to? We have negative 3 equals negative 3 plus b.
It's 0.
It's a 0. So if the y-intercept is 0, where does this line go from? Go through?
It goes through 0.
Goes through the origin. And this circle has a center at the origin as well because it's x minus h squared. If there's no minus anything, then that's just a pure circle with the center at the origin. And we proved this, okay?
Mhm.
Without a y-intercept, it has to go through the origin. And that's how you'd attempt a question like this. Again, it's not too bad, right? Like the only math that we did was we found the midpoint and then we found two slopes, and it's just a matter of plugging a number in. It's not too bad. Don't know which ones to do. Let's look at this one. And all of them are going to be pretty similar. Like you just find the slope, you find the distance, and more often than not, that should be enough for most questions. And sometimes there will be a circle involved, but not in this case. So we have A. That is 1, 2. We have B, negative 2, 1. Negative 2, 1 right there. We have C, -4, -2. 2 right there is -4, -2. And then finally we have D at 2, 0, which is here. All right, let me just connect these. And we should get a trapezoid. So something like that, yeah?
Mhm.
Trapezoid is like something like this. Or this line has to be parallel to this line. This is called A, this is called B. These two, if they're equal, it's called an isosceles trapezoid. If these two, they're equal. But this one doesn't look like it's isosceles. Like you can just tell from the sketch that they're not gonna be the same. And the formula for the area of a trapezoid is A plus B divided by 2 times height. But I don't think we need the area here. So what's the question actually asking us? Show that the line segment joining BC and AD. Okay, so we need to find the midpoint of BC, we need to find the midpoint of AD, and we have to prove that it's parallel to both AB and DC. All right, so AB and DC, cool. So let's first find the midpoint of BC. What's the midpoint of BC? You're given both points here.
-3.
And for the other one, AD is going to be 3/2 and 1. So those are the midpoints, and we need to show that a line that connects these two is parallel to both AB and DC. All right, so we need to find 3 slopes here. We first need to find the slope of these 2 points, BC to AD, the midpoint between them. So the slope here is going to be, where am I looking at? Like this. So the rise is 1.5. The run is 4.5. Goes from -3 to 1.5, so that's 4.5. And it's gonna be positive, so that's 1/3. So that is the midpoint. Oh, sorry, that's the slope between these two. What is the slope of AB? What's the difference in rise?
1,
What about the run?
3.
3, right? Now we're gonna do the same thing with DC. Between these two, the rise is 2 units. And the run is 6 units. Right? Yeah. -4 plus -2. So it's positive because CD is going up as well. So that is also 1, 3. So all 3 of them have the same slopes, right? So they
Mhm.
are parallel. So that's part A done. Part B says, show that the length of this line segment is half the sum of the lengths of the parallel sides. All right, so we need to find the distance between these two. So again, remember distance is gonna be x2 minus x1 squared. So 1 minus -1/2 becomes plus. And same thing with this 3/2 plus 3 squared, like that. So 1.5 squared plus 4.5 squared, square root of that. That gives me 4.74. And then annoyingly enough, you also have to find these two distances, which is 1 plus, so that's square root of 10. And between these two, that's 4 plus 6 squared. That is root 28. So let me double check if this is half of these two. So root 28 plus root 10 divided by 2. And that should be that. So root 28 plus root 10 divided by 2. It is not that, but it's close enough. And we are done. Cool? So there are just a lot of manual computations. And again, the only thing we are doing here is finding the midpoint, super easy. Finding the slope, which is like grade 8, 9 stuff. And then finally, we're using the distance formula, which is something that's brand new. So these are the three things that we use. And if it's a circle, then just know that on the right-hand side of the circle, you have a r squared, where r stands for what? The radius. Let's look into some radical stuff. It's here, 163. All right, let's move on to radicals. So here we are given two radicals, and the question says express both of them as a mixed radical in its lowest terms. Mixed radical means something like the one in part B, where you have a number on the outside and a number on the inside. That's called a mixed radical. So how do you simplify a mixed radical? What you want to think about is this. What's the biggest perfect square that the number inside is divisible by? And when I say perfect squares, I mean stuff like this. 1 squared is 1, that doesn't really count, but 2 squared is 4, 3 squared 9, 16, 25, 36. All these are, perfect square numbers. So when you're trying to simplify a radical, step 1, you're going to ask yourself, what's the biggest perfect square number that the things inside the radical are divisible by? So which one of these is the biggest factor of 72? Is it 49? Does 49 go into 72?
No.
Is it 36?
Yes.
Yes, so the biggest perfect square that you can fit in within 72 is 36. So then what you do is you're going to rewrite this as, well, you have a 36, but then to get 72, you have to multiply that 36 by 2. Step 1. Step 2, then you're going to split apart the radicals. Like this. It becomes root 36 times root 2. Or you can just put a dot if you don't want like the times. You're allowed to split up radicals when they're being multiplied or divided. So finally, square root of 36 is 6, and root 2 is just root 2. And that is the answer as a simplified mixed radical. Let's type part B. What's the biggest perfect square that 27 is divisible by? So again, we're thinking of these numbers. What's the biggest one that goes into 27?
9.
9. So you're going to rewrite this as 5 on the outside is on the outside. Then there's a 9. What do you need to multiply 9 by to get 27?
3.
and then you're going to split it apart like you did. So it becomes 5, root 9, root 3. Root 9 is a 3, so this becomes 5 times 3 times root 3 becomes 15 root 3. You can multiply the numbers by the numbers, and you can multiply radicals with the radicals. Like, for example, square root of 3 times square root of 2 is square root of 6. You're allowed to multiply the radicals, but you can't multiply a number with a radical. For example, 3 times root 3 won't be root 9. It'll simply be 3 root 3. So multiply the number with the number and the radical with the radical. So now this is the opposite. We're given a reduced mixed fraction, or sorry, mixed radical, and we need to convert them into strictly radicals. So we need to work backwards. So how do you work backwards? Basically what you do is you turn your whole numbers into square roots. So for 4, I want to write that as square root of something. What do I write? What is 4 a square root of?
16.
So you can rewrite that as 16 root 5. And now you can combine them with that, and that becomes root 80. What about this one? How do we rewrite -6 as a radical?
Square root of 36.
What about the negative sign?
The -1 on the outside.
Yeah, the negative will be outside like this. And then you multiply the two numbers in the roots, then you get negative square root of 108, and you're done. That's it. So to reduce it, you divide it by the perfect square. To unreduce it, or to take it back into an entire radical, you just write it as a square root. I don't know when you would do this though. Very rarely would you go backwards. This is desirable. So now we are doing multiplication. Remember, you can multiply a radical with another radical. You cannot multiply it with a number. So what's square root of 5 times square root of 11?
Square root of 55.
That's it, and you're done. Because you can't really reduce this. What about the next one? So again, here you're going to multiply the number with the number. So multiply -4 with the 2. And then you're going to multiply the radical with the radical like this. So -4 times 2 is -8, right?
Mm-hmm.
What's root 6 times root 6?
Root of 36, which is 6.
So you get -48 as the final answer. Root a times root a is straight up a, okay?
Mm-hmm.
The radical disappears. It's basically taking the square root of a square. So this question, we have a trapezoid. It is not isosceles. Remember, isosceles means this length has to be equal to this length. For a trapezoid, this has to be parallel with this side. To find the area, it's not asking us to find the area, but if we wanted to find the area, we would need the height. But here this is asking us to find the perimeter. To find the perimeter of any shape, you just add all the numbers up, all side lengths. So we have root 8 plus root 18 plus 2 root 3 plus root 12. Now, to add radicals, you need the same radical component at the end. To multiply, you can just do it with any two numbers, but to add them, you're gonna need like terms, which means you can't add root 8 with root 18. So let's reduce these. What's the biggest perfect square that's a factor of 8?
It's 4.
So you write that as 4 root 2. 18 is 9 root 2, right?
Mm-hmm.
Root 3 is root 3, can't really touch that. What about 12?
4.
Then you have 2 root 2 plus 3 root 2 plus 2 root 3 plus 2 root 3, like that. And now these are like terms. It's like saying 2a plus 3a, that's 5a, or 2 apples plus 3 apples, that's 5 apples. 2 root 2 plus 3 root 2 becomes 5 root 2. And 2 root 3 plus 2 root 3 becomes 4 root 3. And that'll be the final answer for this question. So to add or subtract, it needs to be in the right form, or they need to have the same radical component. You cannot add these two. You can't do anything with 2 root 2 plus 2 root 3. You just leave it as that. Let's look at this one. It says simplify. So we have two terms being multiplied with two terms. It's going to look like this. What'll be the first term?
6.
What'll be the second term? 3 times root 24 is 3 root 24. The next term, we're multiplying a radical with a number again. Negative 6 times 2 is going to be 2 root 6. And then we have negative 6 times negative 24, which is what? 120 plus 24, 144. Like that. This is a 12.
Mm-hmm.
2 root 6, you can't simplify that. None of the perfect squares go into 6. The smallest perfect square is 4, doesn't go into 6. The next one is 9, doesn't go into 6. So you can't do anything with that. But this 24, we can do something with this. What's the biggest perfect square that goes into 24?
It's 4.
4. So this becomes 4 root 6. So we have 6 minus 12, negative 6. 3 times 2 is 6. So we have 6 root 6 minus 2 root 6, which is 4 root 6. And that'll be the final answer as a lowest mixed radical. Now let's try this one. Remember, you can either use this formula. A minus b whole squared is a squared minus 2ab plus b squared. That's one approach. Or you can write it as this. 2 root 5 minus 3 root 7. And then you can multiply this with itself like this. What's the first term?
4 root 5.
So the root 5 also gets squared.
So it's 4
20.
times 5.
Yeah. It'll be 4 times root 25, which is 4 times 5, 20. What's the second term? Here, I'm gonna use this. So it'll be 2 times a, which is 2 root 5, times b, which is 3 root 7. And the last term is gonna be 3 root 7 squared, like this. And for 20, what we did was we did 2 root 5 squared, like this. So 4 times 5 is 20. 9 times 7 is 63. Yeah, it becomes a plus, so plus 63. And for the middle term, we have 4 times 3, 12, root 35. So it's 83 minus 12 root 35. And root 35, you can't reduce it because no perfect squares goes into 35, right? Yeah. The only things 35 is divisible by 7 and 5. Doesn't have any other factors, and neither of them are perfect squares. So that'll simply be the last answer for this question. It's honestly not that difficult. Let's try the next one. All right. Calculate the length of a diagonal of a square with side lengths 4 centimeters. So we have a square. Pretend this is a square. Side length is 4. The question's asking us, what is the length of this diagonal? How do we do this?
It's just gonna be like the square root of 32.
Can we reduce this?
It goes into 16 twice.
Yeah. So it'll be 16 root 2, which will be 4 root 2. What do they want? Length, so it's gonna be centimeters. It's done. That makes sense?
Mm-hmm.
There was a I don't know, like an awareness pamphlet during the COVID era, which says something like this. You stay 6 feet, right? It was 6 feet. You need to stay 6 feet away. You need to stay 6 feet away. You need to stay 6 feet away. Which means these two are also 6 feet. Is that true or false?
It's false.
Would it be more than 6 feet or would it be less than 6 feet? Yeah, it'd be more. But there was like pamphlets like this going around, like where this is 6, this is 6. But we know that's not true, right?
Mm-hmm.
What are your predictions on this? Which one will be bigger, the first one or the second one? So for this one, if you know the formula, you have the answer. So let's just first see what intuition says. So for example, A is 3, B is, no, let's pick some nicer numbers. Let's say A is 4 and B is 9. Let's plug it into this. Root 4 plus root 9 squared. 2 plus 3 squared. 25. Let's plug that in here. So we have square root of 4 squared plus square root of 9 squared. So we have 4 plus 9, we have 13. Which one was bigger?
The first one.
So we show that that's true for one example. But how do we show that it's the case for any example? It doesn't matter A and B, what the value of A and B is. Let's look at this. We have A squared, sorry, we have A plus B whole squared, which is the same thing as A plus B times A plus B. Alternatively, you can use this formula. A plus B whole squared is A squared plus 2AB plus B squared. So here, if you FOIL this, you'll see that you get A, right, squared, or actually you'll get A root A squared, which will be A, plus 2 times AB plus root B squared, that'll be B. So this is what this simplifies to. What does this simplify to?
A plus B.
A plus B. Notice how these two numbers are always positive. Bigger than 0 means non-zero positive numbers. This first expression will always have an extra term in the middle of 2AB, which means the first expression here will always be bigger than the second. This one will always be bigger than the second expression by at least 2 root AB, by exactly 2 root AB, because everything else is the same. Yeah? So this is always going to be bigger. And you can just FOIL it and show that it has this excess term, whereas this one does not. What about this? I think it's just asking us to combine the radicals. So what's the square root of A cubed? Is it just A? Let's say square root of 4 cubed, which is the square root of 64. Notice that's 8, okay? How do we combine these two radicals? There's a 3 here. Outside there's a square root. How would you combine that? Do we subtract or do we divide?
You divide.
You divide, yes, that's gonna be 3 over 2. Here this will be 5 and 7 over 2, right? What about this one? What's the power of n there? So here, look at this. This has a power of 1. What's the power of the other n? It's 5 over 2, right? Remember, if you have exponents, if you have the same base, here both the base is n, and you have different exponent numbers, to combine them, you have to add them up. So it becomes like this. So it becomes n7 over 2. So you have 5n7 over 2 minus 2n7 over 2. They're like terms, then you get 3, 2, and 7 as the final answer.
Mm-hmm.
Do you understand what happened here?
Yeah.
We need to add the exponents if the bases are the same. Okay, the goal here is to just simplify. I'll rewrite this as x5, y6. Can we reduce any one of them? Are either one of them reducible? The y is. Right, remember you divide by the index. So x5, I guess you can write it as x5 over 2. It doesn't really help us. But what does y become?
Q.
Cubed, yeah, that's it. Moving on here. You open the brackets, becomes pq minus p plus 2q minus 2pq, like that. So open the brackets, there's a like term here. So negative 2 plus 1 is negative pq minus p plus 2q. And you're done. Easy as that. I'm not sure if the square root of 4096 is a perfect number. Yes, it is. So let's look at this one. We have the square root, square root, square root of 4096. Always work on the inside and open your way outside. Square root of 4096 is 64. What's the square root of 64?
8.
What's the square root of 8? What's the biggest perfect square that 8 is divisible by?
4.
4. And then you're left with a 2. That becomes 2 root 2. And that's the answer to that. Now the exponent is missing. The x is in the exponent. How do you solve this one? Remember what to do when the unknown is in the exponent?
You use log.
Yeah, you use logs. That's one way. The other way, here, let me show you both ways. So the log way, you'll take logs on both sides. If you take logs on both sides, you're allowed to bring the exponent down. So this becomes x times log root 2 is equals to log of 256. So x is equals to log 256 divided by log of root 2. So this is doing it by the calculator, which gives us, I think it should give us a perfect number. It's 16. That's one way to do it. The alternative way to do this is to rewrite 256 in terms of root 2. So 256 is 2 power 8. Okay.
Mm-hmm.
Now, root 2 power what is 2? How many times do we have to multiply root 2 by itself to get a 2?
Once.
Twice. Root 2 squared is 2, okay?
Mm.
256 is 2 to the power of 8. 2 is root 2 squared. So I'm going to replace this 2 with root 2 squared to the power of 8 like this. Why? Because both the bases have to be the same for the bases to cancel. So this becomes root 2 16 is equals to root 2x. Cancel, cancel, x is 16. So that's how you do it if you don't want to use logs. Because you're not going to be learning logs, I think. Not yet. So you want to make the bases the same. But log is very powerful to check your answer. You can always straight up check your answers. Let's try doing this. You have a point A at -2 and 7. And then you have another point at 4 and 1. The question is asking us to find the distance between these 2 points. All right, what's the best method to find the distance between these 2 points? What's the rise from 7 to 1?
6.
What's the run from -2 to 4?
6.
So the distance between them is simply the square root of a squared plus b squared, yeah?
Mm-hmm.
Because it's just the hypotenuse. So that's square root of 72, and this we've dealt with it before. This is root 36 root 2. It's 6 root 2. So the line segment is 6 root 2. And root 2 is an irrational number, okay? Know what irrational means? What does an irrational number mean? You can't write it as a fraction. Basically, it's always going to go on forever.
Mm-hmm.
Like 0.33 recurring is rational because you can write that as 1 over 3. Or 0.66, you can write that as 2 over 3. But root 2 is like 1.714 something, I believe. You cannot write this as a fraction. That's why it's an irrational number. And it's usually best to just write it in this form with a root. And it's always going to be, the number always comes before the root. You won't write it like root 2, 5. The order is always 5 root 2. Let's do one more and we'll call it a day. There's a rectangle, 3 units by 9 units. 3 units, 9 units. The question is to find the diagonal. What do we do? There's Pythagoras, right?
Mm-hmm.
It'll be 81, 9 squared plus 3 squared, 9. It'll be root 90. Let's write root 90 as a mixed fraction, or sorry, mixed radical. The biggest perfect square that goes into this is going to be a 9. So it'll be root 9 times root 10. That's 3 root 10, and root 10 you can't write it as anything because neither 4 nor 9 goes into root 10. So that'll be the final answer. The diagonal is 3 root 10 units and you are done. All right, let's call it there for today.
Okay, thank you.
See ya.